All right, welcome everyone. My name is Emelie Ohlson, and today I will be talking about compliance as code and how to do regulated business using public cloud. GDPR, General Data Protection Regulation. In this room here today, how many of you want to be compliant with GDPR? Please raise a hand. And keep them up, please. How many of you knows that you are compliant with GDPR? Keep your hand up. How many of you can actually prove that you are compliant with GDPR? Keep your hand up. So we have one in the room. Congratulations. Today I will present some challenges and possible solutions. It will mainly be focusing on Microsoft Azure, but the principles are the same if we, example, compare it to AWS. But first, a little bit more about me. As I said, my name is Emelie Ohlson. I work primarily in the finance and insurance sector, but I also go into hospitality and media from time to time. I work as a cloud security specialist at Omegapoint Stockholm. We have a few offices around the Nordic countries in Sweden, Norway, and Denmark. And the main idea why I got into this business is using both have my left leg within compliance, but also within IT security, which is where I started when I took one of Sweden's biggest finance companies to the public cloud, even though the high regulations we do have. The primary goal of this session is to understand the challenges we actually do face when going to the public cloud. But I also want you to understand the impact compliance have on our architecture as well as our solutions. And that compliance as code actually can help us move towards the public cloud, even though we might do some changes. And for this session, we will have a reference architecture to have our feet to stand on, so it's easier to actually follow. And it's mainly used in a few industries. But this is the one that we will actually discuss around. And for example, if we start off with Azure Event Hubs, which is a big data streaming platform and ingestion service. We have Data Factory, which is a managed cloud service that is actually built for complex hybrid extract, transform, load, as well as extract, load, transform, and data integration projects. Moving on from that, we have something called Data Lake Store, which provides us with file system semantics, as well as file-level security at scale. And this is also built on top of something called Azure Blob Storage, which has the set of capabilities that are actually dedicated for big data analytics. And then we have Azure Databricks, which is a really cool product. It has a unified set of tools for building, deploying, sharing, and maintaining enterprise-grade data solutions at scale. And it's mainly comprised by two different parts. We have the infrastructure that is used by Azure Databricks to deploy, configure, and manage the platform and services. And then we have the customer-owned infrastructure, which is actually managed in collaboration with Azure Databricks and your own company. And the main idea behind Databricks is that we actually can process, store, clean, share, analyze, model, and monetize data sets. Moving up to Azure Machine Learning Service, which is a service for accelerating and managing the machine learning project lifecycle. And professionals working as data scientists or engineers and similar can use it for day-to-day workloads and workflows where they train and deploy their models. And they also manage something called MLOps, which is machine learning operations. Together with this, we have something called ML Flow, which is a part of actually using Azure Databricks. And it offers an integrated experience for tracking and securing machine learning models, as well as training runs, running machine learning projects, etc. And what it mainly is actually taking care of is the parameters, the metrics, and the model tracking of the model itself of the code runs. And it integrates very, very well with Azure Machine Learning Service, but as well as Azure Kubernetes Service. And then if we go to Azure Synapse, which is an enterprise-grade analytics service. It can actually accelerate time to insight across the data warehouses as well as big data systems, but it also gives us some type of compute. And then we have Power BI, where we can actually perform ad hoc analysis for. But before we jump more into our architecture and how actually we will have challenges with some of these components, let's take a look at the overall challenges that we do face when going to the public cloud. Number one, GDPR, personal data, a favorite of mine. With everything that happened within the EU since summer 2020, it has become a bigger concern about personal data, because we're not actually allowed to send it somewhere outside of the EU unless that country has something called adequate level of security or protection for that data. So when actually talking about cloud services, data location is so important, because we need to know where that data is, where it's stored, where it's processed, who can access it, etc. So this is one of the biggest challenges that we actually do face. Then we also have the support part, where we can get support from different countries in the world. Usually when you go to a cloud provider such as Azure or AWS or any, we do have something called 24/7 support, right? I mean, if everything happens at 2 a.m. in the morning and you really need help because it's a critical application, it's down, or you have unauthorized access or similar, you want someone to pick up the phone right away, right? And to have this solely within the EU is not something that usually works today. We do get support from other countries because we have to. This doesn't necessarily mean that we automatically send our, customers' personal data to a third country. But if we do actually choose to let them into our environment, in that case, yes, it's a big cost for it. And as I said, work primarily in finance, something that financial companies must have, but this is general pretty much for everyone, is that we need an exit plan. And not only because we have legislation that states that we need one, especially when we're talking about critical or business important applications, but it's like, because due to the cloud providers, if you would terminate your own contract, you have 3 months to move all your data from that provider. And same goes for if your cloud provider would actually terminate your contract, you have 3 months. Is there anyone here who actually has done an exit from a cloud provider in 3 months or anywhere, even if it's on-prem? No. I've never done it either. I haven't tried because I don't know if it's possible, but I'll leave that for now. But then we go into key management, and this is the trickiest question that we actually have when it comes to specifically GDPR, because the answer to key management is different everywhere. I think I heard about 10 different type of answers to how we should manage our keys in the public cloud on different finance companies. So it really depends on who the corporate lawyers are, because they are mostly the people saying if we should use, Microsoft managed keys or AWS managed keys, or if we should use our own key management system on-prem, or if we should bring your own key or hold your own key, etc. Should we use an HSM or manage HSM? There are a lot of options. I have a preference, but it's tough. And it also, which type of key management we choose have a huge impact on our services in the cloud. For example, if you would do hold your own key, so we have a key management system on premises, we encrypt our data on-prem and then move it to the cloud. How good of an analysis can we do on that data if the key is still on-prem? We can't really do that much because the infrastructure won't be able to read it. And then last but not least, it's not unique for cloud. It's general for everything, but it's a bigger question when we're actually talking about cloud services, and that's data residency requirements. It's also quite common when it comes to actually financial industry, where we might have legal requirements or we have contracts with customers, etc., that require us to actually keep our data within the borders of our country. So, for example, if I work at a company here in Sweden and they would say we need to keep our data within the borders of Sweden, we need to ensure that to 100%. And that can also be a requirement. Not unique for cloud, but it's a bigger question when it actually comes to the cloud. Right, so let's get back to our architecture, where we would take a closer look at one of the components where we might have challenges. We're starting off with Azure Databricks. And first of all, it stores identity data in the US. So with identity data, I mean, for example, my email address, it will say emelie.ohlson@omegapoint.com, or it can say also my IP address. In this case, it's not your customer's identity. It is data scientists, developers, IT security people or similar that actually works in Azure Databricks workspaces. So those identities are transferred to the United States. And since the United States, it's not a country classified that has adequate level of protection in accordance with the EU Commission, this is not something that we are allowed to do if we're looking at the legislation. Besides that, we have table names and object paths that are transferred. These should, however, never, ever contain any type of sensitive data. If we would do that, it would be a really bad idea. So the best practice in general, cloud or no cloud, this should not contain any type of sensitive or confidential data in object paths or table names. And then we have DBFS, which is Databricks file system. It's Databricks' own type of storage. It's a storage account in Azure. It's a public endpoint. And usually when you say the word public endpoint to someone who works in IT security, we usually twist a little bit and turn. Don't know why we still do it, because it's not usually that scary, but at first step it is. So in this resource group where we have DBFS, it's a resource group that is managed by Microsoft, right? So it's not managed by us. We can't do anything. I mean, we can, but then we would break Databricks. We can't change the network rules. We can't change outbound, inbound, etc. However, we should never, ever store data in DBFS. It's not a good practice, and it's not even recommended by Microsoft or Databricks themselves. So data shouldn't be stored in DBFS, but since we can't control or block the users in the workspace from actually storing data in Databricks, it becomes more of an issue. And as I mentioned, it's managed by Microsoft, and this goes both for DBFS, but also the management plane of Azure Databricks. It's controlled by Azure Databricks and Microsoft. Let's go back to our architecture and look at the next service where we might have some concerns. And is Azure Machine Learning Service. So let's take a look at close at the challenges we have there. There we go. So Azure Machine Learning Service, it stores free-form texts of assets names, such as workspaces, resource groups, experiments, files, images. This is stored in the US, and it's not a data flow that we can actually, block in that sense. It also stores experiments parameters in the States. And then we get closer to a more IT security related topic, but it's that the service itself needs to actually access resources on the public internet. And when I say public internet, I mean the public internet, not like Microsoft Backbone Network or similar, but the public internet. So everything that we do for deployment and management operations goes via the public internet, which can be tricky. But these are some of the challenges with two of the components that we have in the architecture. So what is compliance as code then? Well, it's a part of the solution, hopefully. And what is compliance as code? Many of you have probably seen the picture to your left. Is there anyone here who hasn't seen an information security policy before, or at least heard of it? Okay, 2. But this is something that's very common that we have in pretty much any company. We first have a policy, and then we have some type of guideline, and then an instruction that basically tells us what is the set of internal regulations that we have that we need to follow. But when we go into compliance as code, which is codification of compliance controls, we move towards from the left to the right. We can actually code our different instructions and guidelines and force our infrastructure to follow it. And by doing this, I'm not saying that we should take the entire GDPR legislation or ISO 27001 and just, the controls are much, much smaller than described in these 2 examples, such as that we are enforcing that we have encryption at rest for a SQL database, or for example, in our data lake store, we can set a compliance control that forces you to actually have encryption on. You cannot go around it. So in compliance as code, we have different practices. The first one is prevent. So you remember the example of enforcing encryption on data lake store, for example. If we're using prevent, if you would in your pipelines or similar actually deploy a SQL database and you don't have encryption on, the control will deny your deployment to the cloud. It will say, no, you're not allowed to do this. And it will also hopefully give you a reason why you're not allowed to do it. And then we have detect, which can be similar to an audit. It will allow you to do pretty much anything, but it will every day tell you that you are non-compliant with the compliance control that's in place. And the last one, we have remediate, which will allow you to deploy your SQL database or your data lake store without encryption, but the control will automatically deploy the encryption for you to ensure that in case you forget it, I'm here to fix it. However, when it comes to remediate, it's not a practice I would start with, because since it automatically deploys, especially for different network controls, it can break things in your application because it doesn't consider the entire solution in itself. It only cares about the specific resource, such as SQL database. It doesn't care about the rest. You know the expression, how to learn to walk before we run? I would first start with actually doing detect before moving into prevent. And then when we know how to run, we can move into remediate. And by doing this through code, the implementation, validation, remediation, monitoring, and reporting, it follows a similar life cycle, like our DevOps life cycle, where we mainly have our controls in a state where it affects the deploy of our infrastructure. Let's say we do infrastructure as code, and the monitoring part. And even though when we actually build our controls and know how to, it still follows the whole life cycle, because it's infrastructure as code as well. But when it comes to actually ensuring for our DevOps teams that we do have, it's in deploy, where we actually can prevent, detect, or remediate, where detect also goes into monitoring, where we see day-to-day which type of compliance state we actually do have for our infrastructure. So let's go back to our architecture that we had in the beginning. So we had a few challenges with Databricks and with Azure Machine Learning service. And let's say the company we work for now, which is a finance company for this example, they say, no, the information owners, we don't want to send employees' email addresses or similar to the United States, and we don't want to send anything from Azure Machine Learning Service either, and we don't really feel comfortable that it needs to go out on the public internet to do management operations, right? So when this happens, it's quite common that we actually need to change our architecture or revise it to something different. And that's what we had to do to this. Ingest and store are pretty much the same as before. We removed Events Hub since it doesn't fulfill a great purpose when we needed to remove Azure Databricks. And here we instead put in Synapse Analytics, both Apache Spark, but Synapse SQL as well as Cosmos. And we use, in this case, we use Apache Spark to actually clean and transform our structureless data sets and combine them with structured data from operational databases or data warehouses. And then we can also use scalable machine learning and deep learning techniques, such as using Python, Scala. We can use .NET or other different notebooks experience that we have in the Apache Spark tool. And we also have the Synapse pipelines that we can utilize to actually access and move data at scale within this. And Cosmos DB is a great tool here because it actually can make it very accessible for different web applications that we might have, like end consumers using. So using Cosmos DB here from Synapse Analytics to provide actually the data that we made meaningful and the insights to our end users, basically. So now we've gone through our architecture. We know that we're not allowed to use two different components. We know what compliance as code is. Let's now test it with a demo. And we're going to do this live, so let's hope this works. You can't see it. Do I need to move it? Now you can see it. I'm going to zoom in for you guys. Do you guys see it good in the back? Great. So I like to use Terraform and ARM. We need to use ARM, especially if we're doing custom controls. And I have no really good reason why to use Terraform or why you should use Bicep or any other IAC tool. It's just a preference I have. And this one is called block non-EU, which means we're blocking, or we're not blocking, we're basically doing a whitelist of which data centers are we allowed to use and deploy to. And the most important parts are actually in the parameters, where we actually clearly, where we state here. We do have more data centers in the EU, but these are the most common ones. West Europe is Microsoft's biggest data center. That's usually where you want to be. And by putting this to default value, we're saying, hey, you can go here, but you can't go anywhere else. However, in the policy rule and in the control itself, we have a reference to our list of allowed locations or allowed data centers, which was in Europe. But then we also have something called global. And now you're thinking, but we're going to stay within the EU. Why should we allow global services? Well, there are services that need to be global, such as content delivery network. It's the whole point. Let's say we have Jfokus.se. If we want to make that more accessible to all people in the world, we would use a content delivery network so that it's actually stored on different locations all over the world. And which means that its location is global. So that's something we don't want to block. And same goes for Azure Active Directory when we have business to consumers. This is also something you don't want to block, especially if you work a lot with guests and similar, but also if you have applications in the cloud where you actually want to utilize Azure AD for that. and it's a non-regional service as well, which means we should not block it. And now, let's see if we can violate this control that we do have. You guys still see? Good. So we're going to try to deploy a storage account. I named it Emelie Jfokus. And we're going to try to deploy it in the East US and see if this works. And now it said a lot of things. Okay, let's start at the top. So it says it was disallowed by policy, and the reason we get is that resources can only be created within the EU. And then we have the expression value that we put in was the East US, and then target value is some of these, or we also have the field global, or if the expression value would have been, or target value, Azure Active Data, Azure Active Directory, business to consumer directories. And if we continue down, we can also see that the name of the control is block deployment of resources outside the EU. And says similar here, resources can only be created within the EU. And it's really important when we actually implement these controls that we actually state the reasons when you're preventing something or remediate something, so that developers actually know that it's not, you know, Microsoft or AWS that's not working. It's actually something our compliance department or IT security or similar has actually stated that we shouldn't do. Okay, let's take the next one. Next one is that since we're not allowed to use Databricks, as an example, we need to ensure that nobody can actually deploy Databricks. Because usually when we have, like our information security policy or guideline, not everybody knows what says in them. You know, it's like we know it's a paper product and it says what we're allowed or not allowed to do, but it's usually a language on a level that is not that easy to understand. And they will never state you're not allowed to use Azure Databricks. So we also have a control for this, where we say that the values that we can put in for the effects of the control is audit, which is detect. We can also have it disabled. It means, yes, it's deployed, but it's not doing anything. Or we can prevent it with a deny rule. And it's quite easy where we just pinpoint Microsoft.databricks/workspaces, and that should block our deployment of Databricks. But let's try it. And we got an error message saying that it was disallowed by policy and that deployment of Databricks service will enable data transfers outside the EU. This violates GDPR and is not allowed. And as you see, we met the expression value with the target value. And since those is a match, it will actually prevent it from being deployed. And now let's go back to the presentation. Great. So, what did we just do in this demo? We actually enforced our infrastructure to follow the rules of our compliance controls to ensure that we don't do things by mistake, or we have someone that just really wants to use Databricks. I mean, it's a great service, but it's enforcing us to actually be compliant. And working in this way compared to how we usually do it, for example, if we have an internal audit or external audit, If you're going to do that for a critical application at your company, that usually takes 6 months, which is a really long time, and it's so time-consuming. By implementing our compliance controls like this in the cloud at a hierarchy at the top, where all the children has to follow it, we can basically press 5 buttons and get a report. We can give it to the auditors, and we're done. 30 minutes work. Once that audit is more work up hand. But also by working in this way, we're actually lowering our risk. And that's something, especially in the finance industry, when they have to work with risk. They don't have a choice for this matter. So by actually ensuring and saying, hey, we can control all of this, we don't need to actually go and check every single configuration or similar that we do to follow the different rules or legislations that we do have. We are lowering the risk because you can't accidentally deploy Databricks if we have this control in place. So specifically to operational risk, it goes way much lower than it is when we work in the traditional way with traditional data centers. So on premises, even if you have your own or you're outsourcing to a traditional partner. But something that's also really nice with this is that we get something called continuous audit. Since we each and every day can see how compliant we are with the different controls, it makes life easier for so many people, especially IT security, but also everyone who has an interest, since we have to work with this. We need to ensure that we are compliant, otherwise it would be really hard to actually run a business in the finance industry. So actually by getting the audit day to day, or usually you can get it every 20 minutes, but I don't think anyone actually would check their compliance states every 20 minutes, unless you're actually deploying something new to ensure that, okay, what I just deployed to production, yeah, it's aligned, nothing is red or similar, but we actually get continuous audit with this. And the bigger benefits that we actually do get is that we get standardization and consistency throughout all our applications. It doesn't matter if we have 3 of them or if we have 100. We get scalable compliance because I don't need to know how many SQL databases that is deployed in our cloud. As long as the control is on a level in the hierarchy that's higher up than the databases, they will be forced to follow. So no matter if we today have 3 applications and tomorrow we're going to migrate, let's say, 200, we don't really need to do anything about it. It's like, go ahead, because it will scale with it. And one of my biggest all-time favorites must be we have no dependencies. Knowing that I don't need to know how many databases, I don't need to know how many web applications or how many of anything to be able to do this. I can see how many that actually is compliant with the control and how many aren't compliant, but I don't need to have an asset management system or similar to actually check everything. It will be enforced. Cost savings, which is a really good keyword to use for management. Using this, as I mentioned before, doing internal or external audits, it's so time-consuming. Just by ensuring compliance in general to anything, it takes time. But by doing it this way, and we save a lot of time, we save costs. And as I said so many times before, we do get a lot of cost savings. We're keeping compliance up to date all the time, since it iterates, I think, every 20 minutes to ensuring the compliance states of each control, where it is. And a main good benefit as well is that between developers and risk teams, but not only these, it goes for corporate lawyers, IT security, information security, compliance teams, they do get to work closer together. So we become more cross-functional than actually working, within our own little bubble, which is quite common. Because when we actually do get all of these type of teams to actually collaborate and working together, that's actually when we achieve the most biggest benefit for the companies we work for. And continuous compliance, as I said so many times before. It's a very buzzy word in some way, but it's also very important that we actually can know our compliance each and every day from day one. And by that, I say thank you. And if we have any questions in the audience.
Hi. I'm the compliance guy with ING, so that's the reason why we're compliant on GDPR. I have one question. Your current way of working is assuming that developers can do anything, and you, if it's not compliant, you start blacklisting it. How do you deal with the fact that those services that especially Google and Amazon provide change rapidly? So you are constantly need to chase them. By the time that you determine that you're not compliant, you already have an issue because that service is probably already deployed and teams are already using it. Because we do it the other way around. We have a central governor component that you can instruct things to do, and then that component determines if you're allowed to do it. And by default, you're not allowed to do anything unless that governor says you're allowed to do it. What is your vision on that one?
So your question is how we keep track of this since the services change so rapidly in the cloud, right?
Yeah, you're all doing Google, but we also have Amazon, we also have Microsoft.
Many clouds, multi-cloud.
Alibaba, I don't know.
I mean, but some people might have Alibaba Cloud. So it's a really good question. The services we looked at now was core to data flows outside the EU. And at least for Microsoft, this is not something that changes that often. There is a site where you can actually check this. I can provide it in the end of my presentation. Because when a service is regional, let's say it's in West Europe data center, and let's say SQL database that we have in Azure. That service has never happened to me the past 5 years I worked it, that it goes from being regional and completely within the EU, and then suddenly it wouldn't. And these services it's unique cases. It's not a long list of services that do have data flows that goes outside the EU. It's very uncommon. But as well as anything, you should do, monitor everything that happens. You should have a team that is actually dedicated to this, to make sure that, okay, has something changed, et cetera, et cetera. It goes for compliance, it goes for every DevOps team that has services they work with, if new features come or functions, similar. Yeah. So that's usually how I tackle it.
So you're not really going to prevent data leakage issues with this solution?
Sorry,
You're not going to prevent data leakage issues? Because that's usually the biggest concern, is that you leak internal data to public cloud and then somebody might get access to that, which you don't want.
Yeah. Sorry, what was that question?
That you're not going to prevent data leakage issues with this solution.
If I'm going to prevent issues with data leak?
Data leakage.
Data leakage?
Yes.
I mean, I wouldn't say that data leakage is unique for the cloud. It happens if you're on premises as well. There are tools we can use in the cloud for preventing data leakage, such as following zero trust, for example. We have a lot in Azure. We have a lot of tools, such as for actually controlling authentication and authorization. First of all, we have Azure ID. We have identity governance. We have Defender for identities. We have conditional access. We can control our network, et cetera, et cetera. But yes, there are some cases where it actually, becomes scary, such as public endpoint. You just need to think about it differently. Like, for example, if we have Synapse, it has a public endpoint too. But the public endpoint is not to our workspaces or SQL pools. It's the general one. It's like preventing Office.com or OneDrive.com. It works the same way as a SaaS service that pretty much everyone uses here. So what we can control is how our own users are actually using the services that do have our data, because the public endpoint doesn't, except in this case with Databricks. Yeah. We have a question over here. I can read. Oh, no, sorry, there.
There's a lot of talk about, shifting left in security, and when I saw your cycle, I thought of why implementing it at the deploy phase at the earliest, the compliance? I mean, why not at the code phase already, using static code analysis or something? I think you could give a developer a lot earlier feedback than at the deployment phase. Yeah. Do you have anything in place for that?
When it comes to compliance controls, you can have it in your like in your normal pipeline and then in your release pipeline. But as far as it goes for compliance controls, not really. But if we're talking general when it comes to like more IT security, yes, you should have SaaS tools. You should have, it can be integrated to your IDE. You should do threat modeling and those kind of stuff. And then it goes more into the entire life cycle of DevOps. But to demonstrate like where the compliance controls actually hit in the life cycle of DevOps, it's in deploy monitor.
So how does it work if another product like Databricks is introduced? Do you actively have to do something then, or can you kind of blacklist everything that isn't known? Or
one more time, sorry.
So if another product similar to Databricks is introduced, how do you prevent that somebody doesn't deploy this?
The same way we preventing Databricks from being used.
Yeah, but do you have to update the policy then, or how does it work?
Yeah, so what you can do is, when we're talking about specific resources that we're not allowed to use, not anyone, I like to have one control per resource type, because it does happen that in the beginning, when they become general available, they might have, some small data flows. Language understanding in cognitive services is a really good example that I used to have this kind of block on, but then it actually moved that we ourselves can configure so it's within the EU only, then we can remove it. So I usually like to have a control per resource type, but you can, in the template, actually put in a list of resources if you want to. It just depends on how you like to work with it.
Can you also blacklist like everything that is unknown, or?
When you say unknown, do we know, or?
No, like because you don't know what they could introduce in the future.
No, because we need the Microsoft.Databricks or Microsoft.Cognitive Services. We need that path, so we need to know what it is we're actually preventing.
Okay.
But new services usually doesn't just, pop up. We have Microsoft Ignite. They have 2 times per year where they introduce new sub-processes and similar. So there is a way to actually keep track of this.
Is there some metadata available for the services also that you can kind of know roughly what they're doing, or that you can also block on, or?
Yeah, so there is a list. I will provide the link in my presentation, so you can see that. It's not that many. You choose your GEO, it's called, so it's either the States, the EU, or a specific country, and it will state which type of services that they actually have data flows or that do send some things outside the GEO you're existing. More questions? Anyone? Yeah. Oh,
thank you for the interesting presentation. So my question is about the granularity of your control. Have you done more than? It's very interesting that you can block certain product or like not transferring data to a certain region. But to my knowledge, Microsoft is a problem here. So long you're transferring data to, it doesn't matter, it's Microsoft EU, Microsoft US. It's already in violation of GDPR so long you transfer personal data to that cloud. So have you done any more granular control like zero trust, as you mentioned, or key management? Because that's essentially the way, or like the best state-of-the-art technology that you can stop personal data being processed by Microsoft using Terraform, basically, more granular control than just stopping, blacklisting some products or a certain region.
So it felt like more than one question. So first one is, it feels like you're going into something called Schrems 2. Is that something you're thinking about?
Max Schrems 2, you think? Or?
No, I said Schrems 2.
Oh, yeah, Schrems 2. Yeah, Max Schrems 2. Yeah,
yeah,
exactly.
So basically by just, transferring the data to Microsoft, we already have an issue, etc. So this is something that I worked exhaustively with the past 2.5 years, and something I still work with today because it's an issue. And to explain to everyone, Schrems 2 was in summer 2020. It was Max Schrems versus Facebook in a court in Ireland, where the agreement between the EU Commission, the EU, and the US, we had a framework, a contract, about actually be able to transfer personal data to the States. This was torn apart, which is why we have these issues today. Before we didn't. And as you're saying that we already have an issue, there are more controls and more so-called supplementary measures that we can implement to prevent data flows and actually control it. I would personally not say just by transferring to Microsoft, it's bad, because in the end, it's a provider, and one of your providers should be a partner. And if you don't have a trust, it's really hard to work with from the beginning. And then you had like a second question, I think.
It's just more granular control, like enforcement you have done in Terraform. I was just curious, have you done more than that, such as using encryption, tokenization, like enforce that this column has to be encrypted in this database? You can do that?
Yeah, right. You can. So you can do anything from, sky's the limit, I was about to say. But we can force that all the type of infrastructure that is deployed to a specific subscription automatically is joined in a specific subnet, for example. We can, for all types of encryption, we can decide if it should be Microsoft managed keys or if it should be bring your own key. We can do that as well in a control. So you can do a lot with this.
Thank you.
All you need is imagination. Yes. Wait, microphone. No, I can repeat it.
Okay, are there any like standard, these policies that you showed, are there any open source available, nice standard policies ready to use?
Yes, so Microsoft has a big bunch list on GitHub for all type of services they have that is ready to use. Some of them you can choose practice, some of them you can't, which is usually why I do my own, so I can actually decide which practice I want to follow if I want to have prevent, detect, remediate. But they have a bunch as well that you can use. But then it's in ARM only. Might be good to know. Any more questions? You getting a mic?
I have a question about key management. You mentioned that you have some preferences for compliance.
Oh, you're gonna make me say this. A lot of this goes into experience, but also the type of lawyers I've been working with the past years. And it has a lot to do also with how you interpret the court order that came out from Schrems 2, and also the EU Commission's guidelines on this. How that is interpreted is very unique, and that's why key management is so different wherever you go. I would actually run with Microsoft managed keys or bring your own key using Azure Key Vault. Due to modern analytics being a flagship usually for actually going to the cloud, but the hassle of working with managed HSM or encrypting on-prem and going up, you don't have many business cases. You have backup if you encrypt on-prem and then go to cloud. It's all I can think of. But that's my preference, and that's how I have interpreted those guidelines and laws. I'm not a lawyer, I'm just saying that. But that's what I would run with.
Do you think there's any difference between bring your own keys or like Microsoft or the cloud provider managed keys?
Well, if you do bring your own key, we can control the whole life cycle of the keys. in Azure Key Vault. But if we do Microsoft managed, they're still life cycled within Key Vault. It's just that we don't have to do it ourselves. It's automatic. So that's the main difference, I would say.
Okay, so I think it's more convenience than a compliance difference.
Yeah, I mean, I think it's super nice that they change my keys every 3 months, and then a month and a half later, the old key is deleted, etc. I don't need to concern myself about it, because when we go into actually rotating keys and destroying and distributing and the whole life cycle of keys ourselves, it kind of worries me. I mean, I don't want to do that, and I'm an IT security specialist. Yeah.
Okay, thanks.
Thank you.
Okay, maybe the last question, I guess, but
Yep.
have you compared the different clouds policies? Like, do they have more restrictions between the clouds? Like Azure is more flexible than Google, for example, or?
I've never worked with Google Cloud. I had one time the opportunity to might help a client with choosing cloud, and just by reading the data protection agreement of Google Cloud, I said no go. Basically, I had never worked in Google Cloud, but just by reading that, it was quite easy to see that they would probably, at least when I read it, which is 2 years ago, fair to say, that they don't mention anything what they would do with encryption keys in case we use theirs. So.
Okay, thank you.
Thank you. All right, we need to wrap up because it's 11. The presentation will be available, and I will add the links for the different resources so you can see them. Thank you very much.